Alright, good morning. So the next example is to determine the subnet address for each network. So we have two networks here having different number of users. So here we will be using our variable length subnet mask or WLSM. So the address given is 220.10.10.0. So this is a class C address, and then from here we need to calculate for the network address of this network here and the other network. Okay, so as a rule, we need to go first for the highest number of users. So we have our 60 users. Okay, so using the formula 2 raised to x greater than or equal to the number of hosts. So from here we will do our calculations. So we have 2 raised to x greater than or equal to 60. Okay, so from there, what could be the value of our x? So we know that 2 raised to the power of 6 is greater than or equal to 60, since 2 raised to 6 is actually 64. Okay, so 64 is greater than or equal to our 60. So we know that we have our number of hosts having 6 bits. Okay, so from the address 220.10.10.0, so here we will use the binary notation. Okay, so from the rightmost side we will get 6 bits. So we have 1, 2, 3, 4, 5, 6. Okay, so we have here our 6 bits. So the address now would become, this is 8, 16, 24, 25, 26. So this is a slash 26 address. So we know also that the hop here is actually our 64, the number of hop to the next subnet address. Okay, so from there we have our first subnet. So this is under the 60 host. So we have 220.10.10.0/26 until, okay, until what? Remember, we have our next subnet. So second subnet under 28 hosts or users. This will start at our dot 64. So we have 220.10.10.64. So number less than the next subnet is our last address for the first subnet, which is our 220.10.10.63/26. Okay, so next we know that the second subnet will start from 220.10.10.64. Here we will get again the number of bits. So going back, you have 2 raised to x greater than or equal to our 28. So what number could be the power of 2 to have a value greater than or equal to 28? So we will use 5. So 2 raised to 5. What is 2 raised to 5? So we have 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. Okay, so we have 32 greater than or equal to 28. Okay, so we have our next hop at 32. So the next address would be at our 32. But here we are just expected to give the second subnet. So from the address given, we have 220.10.10. What is 64? That is 0, 1, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8 bits. So that's our .64. We will get 5 bits from the host. So 1, 2, 3, 4, 5. Okay, that becomes our slash 27. 27 coming from 8 bits here, first octet, plus the second octet, plus the third octet, which is 8 times 3, that is 24, plus 25, 26, 27. So we have our slash 27. Slash 27. Okay, then we know that the next hop is 32 addresses. So we have 32 plus 64, that is our 96. So less than 1 to the next subnet would be our 220.10.10. What is 96 minus 1? That is 95. Okay, slash 27. Therefore, the first subnet, which will use 60 hosts, will have the value of the addresses 220.10.10.0 until 220.10.10.63. So what is the subnet mask of the first subnet? Okay, subnet mask of first subnet. So how do we calculate for the subnet mask? We need to put all under the slash, the host side to 1 and the network side to 1 and the host side being 0. So we have 1, 2, 3, 4, 5, 6, 7, 8. For the first octet, we have 1, 2, 3, 4, 5, 6, 7, 8. Second octet, and then we have 1, 2, 3, 4, 5, 6, 7, 8. Third octet, that is our slash 24. Since this one is a slash 26, then we have our first and second bit of the last octet, and the rest will have a value 0. So we know that this bit here is 128 and this is 64. So remember, 1, 2, 4, 8, 16, 32, 64, 128. So that's 128 plus 64. So this address would become 255.255.255. This is, we have 192. Okay, that's 4 plus 8, that is 12. 2 carry 1. 6 plus 2 plus 1, that is 9. And then we have 1, bring down 1, that is 192. Okay, alright, sorry. And so next we have subnet mask of second subnet. Okay, so we have a slash 27 value for our second subnet. So again, we will just copy 1, 2, 3, 4. That's first octet. 1, 2, 3, 4. 1, 2, 3, 4. Second octet. Then we have for the third. Okay, third octet. Remember that it's a slash 27. So we need to borrow 3 bits for our network bit. So we have 1, 2, 3. Then our host bits being 0. Okay, so we need to do convert this one. We have 255.255.255. This is 128, 64, and 32. So actually it's the same as 192 plus our 32, which will give us 224. Okay, so that is 32 plus 92. We have 2 plus 2, 4. 9 plus 3, you have 12, carry 1. So 1 plus 1 equal to 2. So that would be our subnet mask. Okay, so let's check for the usable IP. So usable IP address for the first and our second subnet. So under the first, okay, So since the first address would be our network address and the last address would be our broadcast address, then the usable IP for this one is we have 220.10.10.1 until our 220.10.10.62. So those are the addresses that we can assign to our 60 users. So actually more than the number of expected users. Next, for subnet number 2, so we have the address 220.10.10.64 until .195. So again, we will add 1 on our network address to get our first usable IP address. We have 220.10.10.65. Okay, until, so we have to deduct one value from our host, so that will be 220.10.10.94. So that would be the number of usable IP addresses, okay, IP address range for our subnet 1 for 60 users and subnet 2 for our 28 users. Okay, I hope it was made clear for all of us. So actually, there are a lot of other ways on how to do this one. But for this is the basic calculation of our subnetting. So I hope you're able to understand the discussion, and we'll have more of this as we go on with our lecture. Thank you for joining our discussion.